Children, today in this lecture we would be talking about magnetic field in a circular wire which carries current. We have already discussed the magnetic field lines in a straight conductor. So in continuation with that, we would be talking about magnetic field lines in a circular wire. So let us draw a circular wire first. So let us say that we have a circular wire. This is the circular wire, and we connect this wire to the positive and the negative ends of a battery or a cell. So we can mark the direction of current. Let us say this is the wire, positive and negative. So current is entering into the loop and then coming out. So how would be the magnetic lines? If you do this activity by using iron filings, what would be the pattern? Let us try to understand. We take a cardboard and mark and make two holes. Let us say these are the two holes. We make two holes and pass a wire, a circular wire. Let me make the wire with a different color. Let us say this is the wire passing through this, and these are the two ends of the wire connected to the positive and the negative terminals of the battery or a cell. On connecting this, if you sprinkle, this is the direction of current. If I mark this as point A and point B, this these 2 points, at these 2 points we will sprinkle iron filings. If you sprinkle iron filings, you would find that the iron filings, they get arranged in circular pattern this way. You will find that the iron fillings, they get arranged in circular pattern this way, like the straight conductor. Here also at point B, you would find the magnetic lines this way. If you continue drawing this way, the circles would become bigger and bigger. So this is the pattern in which the magnetic lines are formed. So let us try to understand why these type of rings are produced. Okay. Now if you see the loop, this is the loop. We have got this as the loop. This is point A. We had marked this as point A and this is point B. This small part in this conductor, this part which I am marking it with red, if you make infinite number of small pieces, अगर आप इस सर्कुलर वायर को छोटे छोटे टुकड़ों में कट करोगे, हर छोटा पार्ट, every small part would behave as a straight conductor. So this part near point A is a straight conductor, and at B also it is a straight conductor. So we have connected this wire to the battery. What is the direction of current at point A? At point A, the direction of current is upwards. So at this point A, if we are using right hand thumb rule, you would get rings here. These are the rings around point A. So these are the rings formed at A. Similarly, at B current is downwards. Again we can use right hand grip rule and make circles here. As you go away from the conductor, the rings becomes larger in size. By using right hand grip rule, you can find out the direction of the magnetic lines. So let us now find out the direction and put the arrows here. At point A, current is moving upwards. So what about the magnetic lines? The magnetic lines at point A would be anti-clockwise. So this is the direction. I'm marking it with yellow. These are the arrows. So these are the arrows which are showing the magnetic lines at point A. And at point B, the current is moving downwards. So if I use the right hand grip rule, the magnetic lines would be clockwise. So if I mark the directions, you can see it very clearly that this would be the direction. So this is the pattern of magnetic lines formed in a circular wire. Now please try to analyze this diagram. If you look at the inner part of the circle, this is the inner part of the circle. If I look at this inner part of the circle, all the magnetic lines are in one direction. So we can make a sentence like, in the inner part of the circular wire, in the inner part of the circular wire, all the magnetic lines, all the magnetic lines are in the same direction, are in the same direction. You can see it very clearly. सारे के सारे लाइंस जो है वो एक ही डायरेक्शन में मूव कर रहे हैं. तो यहाँ पे होगा डायरेक्शन. अगर हम पहले वाला डायग्राम मार्क करने की कोशिश करें, इट वुड बी समथिंग लाइक दिस. दिस इज द डायरेक्शन. ये इस तरह से मूव कर रहे हैं. These are the magnetic lines. So if I look at the diagram and try to analyze, what we are able to see, all the magnetic lines in the inner part of the circular wire are in the same direction. Therefore, what will happen, all the magnetic lines are in the same direction. Therefore, all the magnetic lines, they would get added up and they would produce a very strong magnetic field. Therefore, what we can say, therefore all the magnetic lines, all the magnetic lines of forces add up to produce a very strong magnetic field. तो यहाँ पे स्ट्रेट कंडक्टर से ज्यादा स्ट्रॉन्ग मैग्नेटिक फील्ड प्रोड्यूस होगा. All the magnetic lines are in same direction. Now again let us see the diagram. If you come towards the center, the rings are becoming bigger and bigger, and towards the center if you move, you can see that the lines are nearly becoming straight and parallel to each other. Towards the center of the circular wire, we can make another sentence. As we move towards the center of the circular wire, the magnetic lines nearly become parallel, nearly become straight and parallel. Okay, so these are the few informations about the magnetic lines produced in a circular wire. Now let us come to the factors which are affecting the magnetic field strength. Let me draw the diagram again to study the factors. So we have a circular wire. This is a circular wire, and we have connected this to the positive and the negative terminals of the battery. This is the direction of current in this wire. And how are the magnetic lines? The magnetic lines are concentric circles. Let me draw 3 circles here and 3 circles here so that the diagram looks, and this is the diagram. This is the diagram of the magnetic lines. Now let us put the directions. The direction would be something here. This is the direction. All the magnetic lines are moving in the same direction. So this is the overall direction of magnetic field line. The blue line you can see. Okay. So factors. If I make this loop of a smaller radius, the first factor, like if we write factors on which magnetic field strength in a circular wire depends. Circular wire depends. The first one is obvious. What would be the first point? The first point is current. If you increase the current, more is the current, more would be the, or stronger would be the magnetic field. More is the current through the conductor, through the loop, we can say, through the loop, greater would be the magnetic field strength. Greater would be the magnetic field strength. What would be the second one? Let us try to see the diagram. If you see the diagram, if I make this loop of a smaller radius and I keep the same current हम उतना ही रखते हैं, मान लो I करंट फ्लो कर रहा है, पर हमने अभी क्या लिया, अब हमने इस लूप को छोटा रेडियस का कर दिया. If I make this loop of a smaller radius, what would happen? I am having the same current, the same conductor through which current is flowing. Now what is the difference in these two diagrams? In these two diagrams, the difference is the radius of the loop. If the radius of the loop is decreased, the second factor, if the radius of the loop is reduced, if the radius of the circular wire is reduced, what would happen? The magnetic lines of forces would come very close to each other. They would come very close to each other. And we have already learned that the closeness of the magnetic lines determines the strength of the magnetic field. So if I reduce the radius of the loop, the magnetic lines would come very close to each other, and if they come very close to each other, the magnetic field would increase, or we can say the strength The magnetic field strength increases. Magnetic field strength increases. So we can write lesser the radius of the loop, lesser the radius of the loop, lesser or smaller the radius of the loop, stronger would be the magnetic field. Stronger would be the magnetic field strength. Magnetic field strength. So these are the two factors. Now a third factor. One, like I have taken only one loop, one turn of wire. If I increase the number of turns, अगर हम इसमें वायर्स को एक टर्न की जगह और बहुत सारे टर्न्स कर ले, नंबर ऑफ टर्न्स, if I increase the number of turns, naturally the magnetic field would increase. So more is the turns of copper wire or conductor, we can say, greater would be the magnetic field strength. Okay, so this is all about the circular wire carrying current. In our next lecture, we would be talking about another arrangement which we call it as solenoid. So let us wind it up today. So this is all for this video. Thank you very much.